Given quadrilateral gold with coordinates G at -1, 0, O at 5, 4, L at 9, 2, and D at 3, -2, use the theorem in item 4 to show that the quadrilateral gold is indeed a parallelogram. For this particular part, I'm going to give you 4 minutes again. Now, this time it says use the theorem from number 4. Number 4 states that we must show that opposite sides are both congruent and parallel. So in order to prove parallel, remember we have to prove slopes similar, or slopes the same actually, and congruent means that the sides have to be equal. And if I can prove that, then I can show that that quadrilateral, based on this theorem that we just completed, that it's a parallelogram. So go ahead and pause your video for the next 4 minutes and work through question number 5. All right. So here I went ahead and I drew my figure off to the side in the My Notes section. But I was able to, and I did it one of two ways. I looked at GO and LD first. They both had a slope of 2/3, and they both had a distance of the square root of 52. So I've proved opposite sides congruent and parallel. Okay. I then looked at OL and GD because those are also opposite sides. I was able to prove that both of them had a slope of -1/2, and both of them had a distance of square root of 20. So those were also sloped the same, which means parallel, and distance the same, which means congruent. So either way, looking at OL and GD, those are parallel and congruent. Or we could say that GO is parallel and congruent to LD. Okay, so you could have gone either way there, but you still would have gotten the same result, the fact that this is a parallelogram. Go ahead and we're on to our next section.